Okay, now this is the continuity of the video that I uploaded earlier. I hope you might have watched that video that I uploaded explaining the permutation and combination question, and we will discuss the B part of the same question, which is 12 in this video, right? Okay, so we will be discussing the B part in series. Now, let UR and VR for R belongs to Z plus. So UR is given, at the same time VR is also given. 1 divided by R into R plus 1, R plus 3, R plus 4. While doing these kind of questions, you have to be very careful because soon after explaining the permutation and combination a question, I explained this question also, but I made a mistake and I couldn't get the answer again. So I am recording the video again. So you have to be very careful while doing these kind of question. One small mistake can ruin your life. This is what I am doing. This is what I am telling again and again. And VR is also given. VR is equal to 1 divided by R into R plus 1, R plus 2 for all R belongs to Z plus. Now we have to show that VR minus VR plus 1 is equal to 6 into UR for R for all R belongs to Z plus. So for this proof, we have to take LHS and show that is equal to RHS. That is the idea, nothing. So we will take LHS VR minus VR plus 2. VR plus 2. Now VR is this. So it is given 1 R into R plus 2 R plus, I'm sorry, the same mistake I made there, right? So I wrote R plus 2 and R plus 3, then I couldn't get the answer. Again I'm making, I don't know why. R plus 1, then R plus 2 minus, again you see, instead of R plus 2, instead of R, we have R plus 2. So here R plus 2, R plus 2 plus 1, R plus 2, 2 plus, R plus 2 plus 2. 1 divided by R plus 2, R plus 2 plus 1, R plus 3, then R plus 4, R plus 2 plus 2. Now the LCM of the denominators, right? See R plus 1, R plus 2, R plus 2 is common, R plus 3, R plus 4. So R into R plus 1 into R plus 2 into R plus 3 into R plus 4. This is the LCM. Okay. Now you have to divide LCM by this denominator. Okay. So R into R plus 1, R plus 2. These two will be remaining there. So R plus 3 into R plus 4. Now we have to show that this is equal to 6 times UR. That is equal to what? 6 divided by R into R plus 1, R plus 3, R plus 4. Okay. Now you see, this should be the final answer. But in the denominator, one term is missing. R okay, R plus 1 okay, R plus 2 is not there. So in the denominator, R plus 2 has vanished. So we should obtain R plus 2 in the numerator also. Then only they can cancel each other. Okay, this idea should be in mind with experience. R plus 4 minus R plus 2, R plus 3, R plus 4. So R into R plus 1 is there. Now you see, again you see, we have, now you see, here R plus 2 is also there, but here missing means R plus 2 should have been there. So this should have been cancelled each other. Then 6 also should have been there. So in the final answer, this is how it should appear. Now you see, after simplifying this, I should get this expression. So 6 times R plus 2 divided by R into R plus 1, R plus 2, R plus 3, R plus 4. Now this and this will go. This will give you 6 in divided by r into r plus 1, r plus 3, r plus 4. So this is equal to 6 ur because 6 times 1, 6 is there. This is equal to ur. Okay. Now I didn't simplify this expression, but I predicted that after simplifying this, I will get this. Why? Okay, because of, okay, now from the answer I predicted that. But if you want to go with the legal way, I mean, you have to come from the question without seeing the answer. That is very simple. You just want to simplify this, right? So r square, this is equal to, now I am separately simplifying this expression, right? So this is equal to, I am just simplifying this here. I have to expand this. R squared plus 3r plus 4r, 7r plus 3 into 4, 12. R squared, I am writing here, okay? R squared plus 12r, I am sorry, 7r, okay? 7r plus 12 minus r squared minus r. So this and this will go 6r plus 12, then 6 into r plus 2, right? So 6 into r plus 2. So I wrote here, and we have proven the first part of the series question. Now hence show that summation of r is equal to 1 to n, ur is equal to some expression. Okay, so you should have been familiar with this kind of question, right? So we have shown that vr minus vr plus 2 is equal to 6 times ur. Now they are asking to find out summation of r is equal to 1 to n ur. Now they have defined values for r from 1 to n. Now I have to iterate, I have to substitute. R is equal to 1 up till r is equal to 12. So now when r is equal to 1, 6 ur is equal to v1 minus v2. Okay. When r is equal to 1, yeah, this is also one of the mistake I made while I was recording the video after finishing permutation and combination. You see, r is equal to 1. So 1 plus 2, not 2. This is 3, okay? This is 3. Then again, r is equal to 2. 6 u here is 1. 2 is equal to v2 minus v3. Okay, 2, 3. Now, r is equal to 3. When r is equal to 3, 6 u2 is equal to, because when we sum up, we have to find out the terms that are cancelling, that are being subtracted or that are vanishing. Okay, so v3 minus v4. Now you see, when we add, now v1 we don't have v2 here, v1 here, minus, now we have plus v1 here, we don't get minus v1. Here we have v3 but minus v3, no, but here minus v3 is there and v3, so this and this will go. Again this and this will go, because when we substitute r is equal to 4, 6 u here 3 4 is equal to v4 minus, I'm making mistake again. 2 here 4, right, and here 3 means 5. Okay, so here v6. Okay, so likewise it will be eliminated. Wait, r is equal to 1, 6 u1 v1 minus v3. R is equal to 2, 6 u2 v2 minus v4 u3 v3 minus v5, yeah, u4 4 then 6. Okay, okay, okay. I'm really sorry. You see? Okay. Now, after iteration, we have got this system of equations, right? Now you see, V3 is here, minus V3 is here, it will be cancelled with this V3. Now V4 is here, that will cancel with this V4, right? Because minus V4 here plus V4, minus V3 here plus V3. Likewise, here we have 1, 2 up to n. Before that we have n minus 1, before that n minus 2. So in the former part of the series we have considered 3 terms, and in the later part of the series also we have to consider 3 terms. Now we have to consider n minus 2, n minus 1 and n for easiness. So this is how you have to write. Okay. So r is equal to n minus 1. When r is equal to n minus 2, first we have to consider the latter 3 terms. N minus 2, n minus 1 and n. N minus 2, then 6u n minus 2 is equal to v n minus 2 minus vn. Then r is equal to n minus 1. Then 6u n minus 1 is equal to v n minus 1 minus v n minus 1 plus 2, v n plus 1. Okay. Now r is equal to n minus, n. Then 6un is equal to vn minus vn plus 1. Okay. vn minus vn plus 2. Okay. vn plus 2. Right. You see the series here starting from 1, 2, 3, 4 likewise. N minus 2. One extra term is being added. Right. vn. Now 3, 4, 5, 6 like vn, n plus 1, n plus 2. So there is a pattern in the series, in the equations. You can observe that. Now you see which terms can be cancelled. Now vn minus vn is here plus vn. So this will go. But this cannot be cancelled. But before this we might have vn minus 1, vn minus 2 here. So this also will go, but you don't need to write them. You just want to write the first 3 terms, and we have to consider the first 3 terms and the last 3 terms only. Okay. Now summation of n r is equal to 1 to n 6u. Now I have to add all these. 6ur is equal to, now you see v1 plus v2. Now all these terms will be cancelled each other, Now you see minus vn plus 1 minus vn plus 2. Now Vr is given. Now we have to substitute the values. This will be equal to, which means now I can take this constant outside of the sum also. 6 summation of r is equal to 1 to n. ur is equal to, you see now instead of r1, right? So 1 divided by 1 into 2 into 3, 6. 1 divided by 6 plus 1 into 2 into 3 into 4. So 12 into 2. So 1 divided by 24. Minus here instead of r n plus 1. 1 divided by n plus 1, n plus 2, n plus 3 minus here n plus 2, n plus 2, n plus 3, n plus 4. Now I have to simplify this, right? So the LCM is 24. Now 3 plus 4. Uh, 4 plus 5, right? 5 minus, you see this minus, I have taken 2 minus, here also minus, here also minus. So I am taking minus out. So this plus this. So the LCM of the denominator is n plus 1, n plus 2, n plus 3, n plus 4. Now n plus 2, n plus 1, n plus 2, n plus 2, 3 are here in this denominator. So the remaining is n plus 4. So n plus 4 plus, again because I have taken minus out, n plus 2, n plus 3, n plus 4. So n plus 1. Okay. So here this will be equal to, now I can take this 6 here also. Right. What is the expression in the answer? Yeah. So here you see, I can divide the entire equation by 6. So summation of r is equal to 1 to n ur is equal to 5 times 6 is equal to 4415 minus you see 2n plus 5 2n plus 5 divided by 6, because I am dividing the entire equation by 6. N plus 1, n plus 2, n plus 3, n plus 4. So we have shown this also. So this is what they have requested us to show. Yes, 5 divided by 1 by 4, 6 into n plus 1 up to n plus 4. Okay. Now the next part of the question says, hence, no, yeah, okay. Now let WR is equal to U2R minus 1 plus U2R. Okay, so we have shown this also. Let me erase all these things because I will need some space. Okay, now they are telling a hint now. What's the hint? Now let WR is equal to U2R minus 1 plus U2R. Okay. Deduce that summation of R is equal to W is equal to an expression. Now from this we have to deduce this one. Okay. Right. Now how we can do this is, okay. Right. Now I have to find out summation of this, right? So let me take summation R is equal to 1 to n. WR is equal to summation of R is equal to 1 to n U2R minus 1 plus U2R. Now I have to find out this, right? But I have been given this also. From this I have to deduce something like WR is equal to something 5 over 144 minus 24. It has changed to 24. Then it has changed to 4n. let me mark them in a different color so that I can get an idea. Okay, 6. This has become 24. Then this has become 2n. 2n. The 2n has become 4n and 2n plus 24. N plus 2, 2n plus 1. N plus 1, n plus 2, 2n plus 1. Instead of this 2n plus 1 and n plus 4. Okay. Now you see r is equal to 1 to n. Now this expression is summed from r is equal to 1 to n. So when r is equal to 1, I will get, you see, u2 minus 1, u1 plus u2. When r is equal to 2, r is equal to 2, 3, right? u3 plus, when r is equal to 1, u2 minus 1. So u1 plus u2. Then again, when r is equal to 2, 2 into 2, 4 minus 1, 3. 3 plus u4. Right? Likewise. Then when r is equal to n, now u2n minus 1 plus u2n. Okay. Now you observe this. Earlier we added u1 plus u2 up to un only. But here you see u1, u2, u3, u4 up to u2n. So we are taking, now the number of terms are double. Earlier we added only n terms, but here we are adding 2n terms. Now earlier if we had added 10 terms, now we are adding 20 terms. So now this makes now this expression has transformed the series to 2n. So now this is basically equal to, now after summing this expression, now we get summation r is equal to 1 to 2n, right? So if I substitute, I get 1, 2, 3, 4, 5 up to n, then 2n minus 1, you see 2n, u2n, right? So the number of terms are double, 2n ur. Okay. Now this is simple. We already found out that summation of you see earlier. Now this is what we have to find out, right? So you see, okay. Yes. Now earlier summation of r is equal to 1 to n ur was like this: 5144 plus 2n plus 5 divided by 6n plus 1, n plus 2, n plus 3, n plus 4, Now we have to sum 2n terms. Now when we substitute, now when we make this as 2n, now it will become, you see, 2n. Now wherever we have n, we have to substitute 2n. Now this will become, instead of n, 2 into 2n. So 2 into 2n will give me 4n plus 5. Then you see 2n. Okay, now we have found out this value. So instead of this, I can write like this, right? So here summation of r is equal to 1 to n WR is equal to, because instead of this we have found out that is equal to this. Now 5, okay, this 4n plus 5. Now in the question, okay, now you see it has transformed to this format. Now we have to transform this expression to this format. You see 24, but here we have 6. Now 2n plus 1. Now it has become 2n plus 1 and it has become 2n plus 3, right? So 2n plus 3, 2n plus 1. Here you see 2n plus 2. Here 2n plus 4. So from this I take 2 out, and from this also I take 2 out. So I can write this here, okay? So summation of r is equal to 1 to 2n ur. So otherwise I can write 1 to n WR is equal to 5 divided by 144 minus, here minus, minus 4n plus 5, 4n plus 5 divided by, you see n plus 1 is there, so I have taken 2 out, and here from here I have took 2 out. So 2 into 2, 6 into 2 into 2, 24, n plus 1, n plus 2, 2n plus 1, 2n plus 3. That's all. And we have come to the last part of the B part question of the 12th question. Hence show that the infinite series. Now the infinite series. Now when n tends to infinity, when n tends to infinity, instead of n they have infinity. So when n tends to infinity, it converges. It converges means now it shrinks, the value shrinks, the value is not infinity. Now we have to show that. Now how we can write the answer for that part is, let me erase all these things. Okay, so we can just keep this. Okay, now I'm erasing all these things. Here 2n plus 1 and 2n plus 3. Here 24 and here 4. Okay. Now when n tends to infinity, now here 144, right? So when n tends to infinity, limit n tends to infinity. Now apparently they have told that it converges. We have to show that it converges. Definitely this fraction will be 0. Now this will be 0. So how can we identify that is equal to 0? Now you divide both numerator and denominator by n. So 5 divided by 144, limit n tends to infinity, minus limit n tends to infinity, 4 plus 5 divided by n divided by 5n. Now I will take only one factor of the denominator, then that will be equal to, let me take this, 1 plus 1 by n into n plus 2 into like that, right? Now you see it has become 0. Then you see this has become 0, but here this is infinity. Infinity times infinity also infinity. Now you see 4 divided by infinity. 4 divided by infinity is equal to 0. Okay. So what I told is, now I divide both numerator and denominator by n. So I divide this value by n. So n by n, 1 plus 5 divided by n. Again you see I divide the entire denominator by n. So I just divide this factor by n. So 1 plus 1 over n. Now this becomes 0, this becomes 1. But here If I put infinity instead of n, then it will become infinity. Then this also will become infinity. Infinity times infinity will give me infinity. But in the numerator we have 4. So 4 divided by infinity is equal to 0. Right? So if you divide any number by infinity, it will give you 0. So here now this is equal to 5 divided by 144. So ultimately we have to write the series converges. This converges, and the sum means the value is this. Okay. I hope you have understood this question. I have explained the 12th question, and in another video I will explain the 13th question. Bye.